Okay. Hello, everyone. Uh, Good afternoon, good evening, good morning. My name is Daniel Santos, and I'm going to spend the next hour with you, sharing, some information about SolidShop and why we are doing this. What is the main points about SolidShop, and I'm gonna cover uh, some functionalities, about this suite of products that we are offering. This is going to be a series of three webinars. Today is the first. We're going to cover in the next hour uh, some of the modules, and then in the second webinar, we're going to cover the other half. And then on the third webinar, we're going to talk about business, costs, licensing, and all the business details that we need to share with you so you can start to operationalize this and sell this product. Okay. So what is SolidShop? Uh, SolidShop is a group of applications that increase our presence outside the CNC programming office. So we are selling, CAM products for almost 40 years now, or 40 years. We celebrate 40 years this year. But essentially we operate inside the CNC programming office. We sell product that is consumed by operators and CNC programmers. Um, but historically we operate on a very saturated segment. We have multiple competitors, and often uh, we need to share, reduce our margin. So I'm having an issue here. So let me just see if I can share my screen, sharing with everyone. Okay, let's see here. Stop sharing and sharing my screen, show my screen. This should fix it, I think. Okay. Can you guys confirm to me that, okay, good. Okay, so I have feedback that is working. So let's go back. We just missed one slide. Okay, so what is SolidShop? Like I said, a group of applications that extend our presence. Uh, and we are operating in a very saturated segment. So often we need to, cut our margins to close deals or kind of stop the growth of our competitors. And that's because we know we have the best CAM product, and that's why we win these deals. But it's really hard for commercial people uh, to show the difference in the very beginning. And SolidShop expands our offering beyond CAM and gives us differentiation because, we have seen here in Brazil, where I'm based, that, for example, we had a deal that where we were competing against Top Solid, and they have a PDM functionality, and the customer was opting for them because they had the PDM functionality. And then we had another opportunity to come with SolidShop and PDM and some functionality, and they say, "Oh, I didn't know you could do that too," and other things that Top Solid could not do. So this differentiation gives us leverage, and then because we have a distinct offering, we have a unique, solution. The customer often wants to stick to, a broader package, and this gives us some differentiation, and we can reduce the discounts and increase our margins. The thing is that, in the past years, um, a lot has been said about Industry 4.0 and all that stuff, and SolidCAM is being very careful to do not talk too much about SolidShop as being an Industry 4.0 solution, although that's exactly what it is. But marketeers from, the manufacturing industry, they abuse the term, and Industry 4.0 became even the things that are on the market for a long time. So, and the other thing is that, they become, right now they are not a commodity yet, so they are very expensive solutions that only, very large enterprises are investing on. So where are the answers for the small and mid-sized companies that want to invest, that want to do something in the digitization field, but they cannot, afford to break the bank like the big companies. I'm sorry. So SolidShop, it's affordable, it's integrated, and it's simple to implement. We can do, for example, a complex implementation covering around 30 machines in 3 weeks, whereas some of these, mainstream solutions that are being, acquired by these Fortune 500 companies, they take like 6 months, a year to implement, and sometimes the projects are not even finished. We see this, stores like that all the time. So SolidShop is really something that can be implemented quickly, and the customers really appreciate that. The other thing is resellers are looking for diversification. They want to sell more products. With the variations we have with SolidWorks pricing year after year, they want to have more products to sell and create, some multiply the sources of income for their business. So we are basically offering, them alternate products while they still gravitate around the SolidCAM ecosystem, the SolidCAM platform. So they don't need to shop with our competitors or offer or partner with our competitors to deliver new products. They can continue with us, which is very important. And I think that if I could summarize this slide, SolidCAM as a product is used strictly by CNC programmers or people, manufacturing engineers and the like. What we are aiming with SolidShop is increase revenue, increase, more our opportunities to penetrate other areas of the manufacturing business, management, production planning, shop floor, quoting, finance, because if we extend this coverage, this portfolio, we become mission critical to a business and deepen our relationship. And if we, succeed in doing that, then our subscription rates will go up as well, because the customers will need these solutions to operate on a daily basis. And then we don't depend only on the CAM system, which is something that they tend to sacrifice when budget is not there. Okay, so these are the products. Everything starts with SolidCAM. So in the top we have SolidCAM sending information to NCBase, which is the PDM, and I'm going to show you multiple examples here about the possibilities for the PDM. It's a very good tool to eliminate non-conformities and help customers with ISO audits and ISO 9001 implementations, eliminate paper, creates a single source of truth. And one thing that we can be very proud about it is that it's a PDM for manufacturing people. It's not a generic PDM like what we see with CAD tools, and it's physically connected to the CNC machine. So I'm going to demonstrate here today how powerful that is. Then, NCBase runs on the top of Simco Edit, which is a product that we have in our portfolio for a few years. The good thing about it is that often when we sell CAM to a customer that didn't have CAM before, they have, parametric programs, handwritten programs, or something that they wrote using a mix of, handwritten with CAM, systems, and then they need to simulate that, or they would like to simulate that. We can automate programming tasks. This is something that we never really explored in the last years, but it's there. And we can also offer affordable machine simulation that covers milling from 3 to simultaneous 5-axis in multiple CNC controls. And we can also offer, turning with C-axis milling. Turning is more limited. We are not able to simulate Swiss type machines or complex mill turns with B-axis units, but we can cover a wide range for a fraction of the price that companies like CG Tech charge for a solution like Vericut. So I'm not saying Simco Edit machine simulation is a replacement for Vericut. I'm just saying if you want to go to a certain depth in the machine simulation and you are willing to give up some very advanced functionalities in simulation or very complex machines like Swiss types, mill turns with B-axis, sub-spindles, then you have a very competitive solution. We have DNC as well. This is the module that not only, sends and receives programs, but also collect the signals from the PLC and the machine utilization. So it can be integrated with the PDM, but it can also feed the real-time machine monitoring module. So DNC Max is the module that captures the information. And MDC, which is the machine monitoring solution, essentially process these signals and determine what is going on the machine and why. I would like to kind of go back here to the PDM product, NC base, a little bit because we also have another product called MDM. Also is also part of the SolidShop. It's another PDM from Simco. If you want me to highlight the main differences is that when you have a manufacturing process that is strictly or very oriented to CNC machining, NC base is the best solution. When you have a manufacturing process that covers multiple processes like welding, assembly and test, painting, CNC machining, and other areas of the manufacturing process, then MDM is a better product because it's more configurable. But the good thing about NC base is that it's very oriented to the operators, very easy to use, and very tightly integrated to Simco Edit. MDM is like a separate product that can handle other situations or handle other types of processes, but it's not so tightly integrated to Simco Edit. But there is an application, the proper application for each of these solutions. If you want a good PDM solution, we have solutions for both situations. MDM is heavily commercialized in Germany, where it's developed. So there's a market for everything. But in general, our customers are gravitating around CNC machining processes. So NC base, it's a better application for that scenario. And then we have Scheduler, which is a solution for production planning and see the capacity of your machines in your shop, if you are using this capacity at its fullest, or if you have gaps, if you need to order or purchase more machines or not. So Scheduler basically tells you in a graphical interface how much work you have to put on your machines. It can be integrated to ERP systems and handle production orders and all that. So I want to finish this slide here saying that all these products that you are seeing on the screen right now, when working together, they become a mini MES system. So they can be configured as a mini MES system. So instead of spending $500,000 or $250,000 to implement a MES system that will take a year to be implemented, with SolidShop we can deliver a mini MES system for a fraction of that price, and depending on the number of machines, within weeks. Okay. So you see the data flows from one modeler to another, sometimes bidirectionally, and that's why we call this an ecosystem, because the data gets out from SolidCAM, enters the PDM, and then it's reused across multiple applications. So what are the key business processes in a machine shop? We know that companies can have hundreds of processes, but let's talk about the very basic ones, okay? Everything starts with the quotation or estimation. Nobody manufactures anything without having an idea of the cost. Unless you are, strictly a prototype shop, or nobody cares about that. But in general, a machine shop needs to know how much it's going to charge or how much something is going to cost to be manufactured. So this is where we start. SolidShop currently does not have a solution for quotation, but we are talking to industry leaders, and we are going to bring, quotation solutions to be integrated with SolidCAM and SolidShop. So we also cover this part of the manufacturing process and the manufacturing business. So we have CNC programming, which is where we operate on a daily basis. Nothing new here for us. So, so the first part of SolidShop is the PDM, the manufacturing PDM. I'll try to make an analogy here. Programmers, they are like composers. Okay, you have an orchestra, and then you have a composer, right? The composer writes, pieces of music to all musicians in the orchestra, but the composer does not execute this music. It's just writes them. So that's similar to the CNC programming process, because a programmer selects and conceives the manufacturing process, select tools, fixtures, all the parts, all the resources that are necessary. He thinks in the order of the operations, which tools in which order, or which side of the part I'm going to machine first. But then all these pieces of music and all this information that was created only exists on his mind. So often we have issues in the shop floor, like operational mistakes or incomplete information, because people in the shop floor, they are musicians. The operators, they execute the music according to the music notation they receive it. But if this is not clear, if it's something or the music for a given instrument only exists on the composer's mind, then people in the shop floor will fail to execute this, because they don't know what the guy thought. So that's where the PDM helps, because the data gets out from SolidCAM, and then it's put on a PDM. So let's say that the tool list is a document, a picture, a screenshot, showing the operator where he's supposed to make the 0 point, the catalog of a tool, a quotation for a fixture, very cut files or simulation files. So everything can be stored in a structured manner. So the people that are going to execute the music, the members of the orchestra, will understand their instruments and the music and the notes they need to play, because the PDM is basically, organizing all the information to them transparently. So the next thing you're supposed to do is, okay, I'm managing the information, I'm informing people about how to execute, their parts. So now it's time to measure and monitor if I am executed as I planned, because everything starts here on the step number 1. I quoted and estimated this to a customer, then I programmed that part to aiming that time or that cost, right? So the first thing, if you quoted to the customer that you need to do this part in 10 hours, you're going to program this part on your consistent to do it in 10 hours or less, right? Otherwise, you are not profitable. Then you're going to, step number 2, the PDM, you're going to put all the information that people in the shop or across the company need to execute as you planned to meet the 10 hours or less. Then you have now to monitor. Am I doing this in 10 hours or less? If not, what is preventing me from reaching the number that I planned? Do I have any problems with tool breakage, or am I waiting for the forklift to bring the material, or am I waiting for the tool crib guy to prepare the tools? If I am waiting, for how long? Because all these things are impacting my cost, right? So I need to track every inefficiency so I know what I did not take into account when I estimated, how much that process would cost. And then the next thing is, I monitor it, but I also need to plan the capacity, right? Because, and to reflect the reality, which becomes a mini MES system. Because first, you need to know what's the capacity of your shop, how many hours per week your machines can work. You need to take into account shifts, maintenance, events, and all that. But the thing is that you here on the quotation and estimation and the CNC programming, you are basically conceiving a process that is ideal. But at the capacitor to reflect reality, you're going to see other problems. Operator did not show up to work today. This machine is out of order, or I have a tooling issue here. I run out of inserts. All these things are pushing or pulling your work orders in the shop floor and impacting the scheduling of your machines. So because you have a product that is connected to the real-time monitoring system, you also have, the ability to tell if these work orders are being worked on or not. If the machine is stopped, I stop booking hours in the work hour, but I am counting. I'm still counting the total machine time. Like I started this work order on Monday, it's Saturday, and I should be finished by Thursday. So the system is monitoring that, but it's also monitoring and booking into the work orders every second that the spindle was running and on that work order, right? So you need to know that. Why? Because you need to use this factual information to quote and estimate better in the future. So like, okay, this is the first time I do this part number, and I did not take into account that I would have so many, insert chains, and tool crew will take all this time to replace the cutters. So I'm going to quote it better next time, or when I have a similar part, I'm going to take that information into account. And that's how you make your profit and your margin more realistic, okay? Because people rely too much on the time that is shown on the CAM system, but we know that CAM systems are limited. They cannot show what really happens. Like I said, um, people not showing up to work, or machine out of order, downtimes. So this is why you need this ecosystem. So now that you understand that, I want you guys to see this picture because it shows, a manufacturing company, multiple departments. Not all of them are involved with manufacturing, uh, but directly. But let's say that today we operate here. That's where our product basically lives, in the CNC programming department, right? With SolidShop, our idea is to have an ecosystem, a portfolio of solutions that can be deployed in multiple departments of the company. And when we do that, we become more mission critical, like I said. The company depends more on our business and our technology. And we believe that this will help us to increase our subscription rates and our margins in general, but also deepen the relationship with these companies because they will be happy with the technology we are providing them and solving multiple business problems instead of only CNC programming. So this is what we see. For example, for the CNC programming department, we can offer SimcoEdit, machine simulation, the PDM, which could be NC based or AMDM, like I said, depending on your needs. And we also have the NC Max, so they can kind of manage all the communication with the machines without leaving the CNC programming office, which is something that management appreciates because programmers are more productive and they don't have to spend time in the shop floor um, solving basic problems. And if they don't have to leave the programming office, it means that they are working more towards process improvements, continuous improvements, programming new parts. So the less time they spend on the shop, it means that they are improving processes or programming new parts, which is their main job, or should be. So here on the management, the president, the director, they can see, real-time information, reports about shifts and performance of the machine and all that. And you can even see the president, seeing that on a cell phone, from anywhere. So he could be like, the director could be here in Brazil, the president in Europe, and he would see in real time what's going on because he's using MDC. Then we have scheduler, which, like I said, shows the real time that was used inside offers and estimates and quoting documents, and this will allow them to um, be more accurate in the future tendering and quoting efforts, and that means the company will be more accurate and their margins will be more realistic and close to what they expect. Finance can also pull reports from the system and see and use it to calculate, for example, the hourly rate of the shop or the need to invest more, in machine tools and things like that, and work with management. So the system is giving them all this information. In a meeting room, for example, you could have MDC and these real-time screens showing, what's going on the shop floor. Um, you can also have the production manager, seeing data from monitoring, but also, pulling documents from the PDM system to check if we have all the resources we need before, we start to work on a given production order. So do we have the tooling? Do we have the documentation? Do we have the fixtures? Do we have all that? So management, shop floor management, and leadership could, check the PDM to make sure that before a production order starts, everything that is needed is next to the machine, and this way they avoid downtime. We also have inspection quality department checking documents, drawings, QA documents that are stored in the NC base or in the MDM PDM. Which means that there's only one single source of information. They could see that in a tablet or in a web browser or something, and there are no printed documents in the shop floor. Everybody sees the same. So if a programmer makes an update on the PDM, with the drawing or with the inspection report, everyone in the shop and across the whole company would get the latest version without printing anything. Production planning would kind of, use the PDM to check if the resources are available as well. Like, I need this fixture, I need this and this and this. Do we have the tooling that we ordered? Can we start this production order? And they can also use the scheduler to plan the capacity of the shop, and also check in real time if things are happening as they planned it. So this is a big nightmare for production planners today, because they plan everything in Excel, and then reality settles in, and then they have to go back to Excel and reprogram their schedules. With this technology, we have feedback in real time about what's going on. And then finally, the production shop, which is the environment where we operate the most today after the CNC programming, where we could have machine simulation, the editor, we can have the PDM, could be MDM or NC base, like I said. And this is a big thing about SolidShop. We want it to be a booster for SolidCAM for operator sales. I'm going to show it to you, and then you're going to see, how this can work together with the PDM and SolidCAM, and also have our operators in the shop floor giving feedback to programmers, making adjustments, and the PDM managing all that. Because one of the things that we hear all the time is, when the programmer makes change in the process, I can track in the office. But what if the operator makes change in the machine? How do I track that? How do I control that? And we have an answer for that with SolidShop, as I'm going to show you. DNC to make the communications. So now I have the guy here, the operating the machine, connected remotely to the CNC programmer, and they can, diagnose, and they can, transfer documents and files without, leaving their territories. MDC Max as well, because they are going to enter downtime reasons and all that. So they also use, real-time reports. I would like to highlight that with the modern CNC controls that are equipped with, Windows operating system, we can even have SolidCAM for operators running inside the CNC control. And this way, operators can not only, make changes, but they can also have NC base or MDM as the, PDM client inside the CNC control as well. or a tablet next to the machine. Anything that can run a web browser can have these clients. So operators can make, change or check the versions or run simulation or all this from the CNC control. So this is also a possibility. This is where we are. We are operating for almost 40 years here on the CAM layer. And of course, if we have a customer that does not have any CAM system and we sell SolidCAM to them, it's going to improve their accuracy and productivity. But now with SolidShop, we have answers for the other layers. Okay, you can see here the PDM layer, very important because it connects people, ideas, methods, enforces standards. This is very important, traceability, transparency, without, printing any paper. And with the machine monitoring, managers make decision based on real time, factual data. And because we have this platform that can be mini MES system, we can integrate and SolidCAM and databases, PDM, DNC, with other business systems like ERP, um, flexible systems, and all that, and connect to the latest, technologies available in the machine tools and shop floor equipment. So just to finish here, this is basically in a nutshell what these products are. We have two packages, standard, which covers, from Simco Edit to machine monitoring, and for shops that want to have scheduling capabilities for their plan the jobs, we have the professional bundle. NC base can be replaced by MDM if that's what the customer wants. I want to highlight that we renamed these products. So NC Base in our ecosystem is called SolidShop EDM, DNC Max, SolidShop DNC, SolidShop Machine Monitoring, and SolidShop Job Planner. Okay, we don't use the Simco names for this product. And to finish, these are the companies around the world that are using this technology. So NC Base, has been around for more than 25 years. The NC Max as well, Simco Edit. We also have the monitoring system that's been around since 2007, so almost 20 years. Very, very tested, very proven technology. Works a lot on around protocols and minimizes the usage of specific hardware. So yes, we can work with old machines or new machines, but if you have a newer machine, which is probably anything manufactured after 2010, 12, you have protocols that are based on software and TCP/IP, which eliminates, hundreds of issues that are created by the technology used by most of our competitors. So now that I showed this to you, okay, I'm going to demonstrate, what this is in a nutshell. So I'm going to open SolidWorks and the PDM module as well. So let me just log in here in the database. So the first thing is that to access the PDM, you need to log in, a password. No one changed the program, and without anonymously. Everything that happens needs to be tracked and is linked to an account and time and a backup and a version. So this is what the PDM looks like. We're gonna open SolidCAM, but this is probably the part that's new to most of you. We can have a CNC program here. So imagine the CNC program as being like a box, like a package. And once you open that, you can see all the documents that you have for that given process. You can use drag and drop functionality. So let me see here, for example, I can go here and link, a document and say, I want to associate this document to my CNC program or my process. And I'm gonna say, this is a PDF, okay? So now the system, basically stores that file and controls version. If I want to make a change on this file, I can go here and say, well, I want to make a change on this PDF. So the first thing I'm going to, back up this version. And then I can go to, Adobe and let me see here if I can change anything yet. So this is a viewer, so you can see this on the PDM client or a web client, but I could open this in Adobe Acrobat. Let's see if I have the edit with Acrobat. And I'm going to call it SolidShop 2024, just to make a difference here. And we're gonna save it. Okay, so now if I go here and open this document, this is the version that I have, right? The current version, because I made change on Acrobat. But I could go here and say I want to restore this version. And now if I open this again, I see the previous version. So you can make, versions, and you can restore, backups and all that. So you have also, a tool list that it's generated by SolidCAM, can be linked to your document, or, just like a setup sheet or something, or a tool list, like I said. You can, associate pictures to your parts. You have here the change view, so you can preview the documents, or if it's a picture, a PDF, you can see that, or you can preview the CNC program. But you always have here the event log, where you can see everything that happened with that document, or with that. So I can see only the preview of my document, or only the log, or both. I can also add notes here that will force anyone that tries to open this document to read it. So let's say we need to wait for the new EMUG top. Okay, so there's no way that someone can say, I did not see that note. Okay, and you can go here and say, change the status. This program is, sorry, not status. This program is locked. It's already locked, you see? So people cannot send it to the shop floor right now because, the document is locked. Okay, so I'm preventing someone from using the CNC program or downloading at the machines because I'm waiting for a new tab as the CNC program. I can unlock this and say, this program is now approved to run. So the system removed the locked, flag here. I can remove the notes as well and can send this program to the machine. There is an integration with the DNC, which I'm going to show you in a minute. And you see here that, at this time of the day and blah, 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 Daniel send this to the machine, okay? So you can see here that I have in the DNC log, I send this to the machine. So let's see what it looks like on the machine. So I have this, Siemens simulator here that allows me to show you what it looks like for the operators, okay? So in the meantime, I'm going to open this. And I go here to the DNC receive. You can see here that, the CNC received this file at 11:42, which was a few seconds ago, okay? And I can simply copy this to the CNC memory and go here in part programs and paste it. I'm going to overwrite because I already had that program in the memory. And I'm going to make a change here. Just, one of these hard to read Siemens cycles here. I'm going to add an extra 0 here and break the cycle. Okay, so this angle here is going to be, let's just say 3 degrees. Basic values. Oh, yeah, I cannot do anything here because swiveling is not activated. So 1 by axis and basic values. I don't think it allows me to change this because this is like a free version of the simulator. So I'm gonna kind of, try a more standard cycle. So this one, let's say that I want to change this coordinate here. Very small value, okay? As an operator, I'm making changes and they are very hard to notice, okay? I'm also going to open this iMachining operation. I'm gonna, delete that small place here. And now that I kind of run this, I'm going to send this to the DNC from the machine. So copy from the machine memory to the DNC. And if I go now to my PDM product, I'm going to show you that I can also, generate changes from SolidCAM. Yes. So now, we have this instance here called import queue that shows me that, we have change that came from the machine. So let's compare and see this change. Time and date, probably nothing else. And what I'm gonna do now, I'm gonna say I'm gonna reject these changes because they don't mean anything to the process, just date and time in the header. You can see here that Daniel rejected those changes. So let's just kind of, copy this again, copy, oops, from the machine memory to DNC. And let's see what the PDM tells us. So the PDM tells us that, there was a change again, and let's compare and see the difference that the operator introduced. So on the right, you can see, on the left, you can see our current version, which is, you can see here that I am comparing my original version with the version awaiting approval, the version that came from the machine. So changes made by the operators do not override the version in the PDM database automatically. They need an approval. And who approves this? Usually a CNC programmer or a manufacturing leader or someone, but you always have control. So you open the gates for operators to make changes, but you have the final word about what gets in. So in this case, we are seeing on the right side the change introduced by the operator. And the system is always making backup. So I'm gonna accept this change, okay? And with this ecosystem, I'm going to open this. You can see that the program is still locked because it's pending my approval. Now to release it to the shop again, I just accept the change. It doesn't mean that I reviewed everything. So now I have, machine simulation. I can kind of, um, add more machines to this setup. I can change the machines. So let's say, for example, that I want to use a bigger machine. So I go here, machine models. I can download them from the database. We can build these machines for you, and the resellers, they can sell that as an extra service because uh, if they have the machine simulation license, and when the customer sends you the machine models to build or post-process the VMID file, you can also use these models to build the machine simulation in Simco and charge for that service. So let's say that I want to put this on a VF5 machine. So I'm going to install this machine. Now I need to close this. I can go here and say, I want to use the VF5 instead of the mini mill. Machine simulation, and now I have a big machine again. I need to adjust this in the SolidCAM interface. So when you go here to SolidCAM, you need to change your post, and here on your setup, you're going to select your mount, everything, and then this is transferred automatically to the interface, including the here, okay? So if I go here to the machine simulation, I also have the tool setup with all the tools that were transferred from SolidCAM. Okay, so this is also part of the interface. So let me just mount this on a machine that has the proper point. So let's say RAHAS UMC. Yep. And then I can kind of go here and say I don't want to see the base. And let's run this process from the beginning so we can see what the operator did. So you are doing G-code based simulation, like VeriCut. You can also go here and say, I want to, simulate this. I want to check the limits of the axis. I want to see what happens when I do this or that. Okay, so this machine simulation is fully functional for up to 5 axes. You can measure things. So let's say, for example, that I want to section the part. So I'm going to reset this because I need to start from the beginning as I move with the axis. And let's say, for example, that I want to, understand what's going on inside the part. I can go here, to my, stock model and say cross section on the Y minus direction or on the Y plus direction. Sorry, Y minus. I can dynamically, push and pull and see what's going on here. I can change the sectioning plane. Okay, so I'm going to reset this, remove off, the cross section is off. And so let's finish this. Okay, so let's suppose that, so I'm gonna make a change here now, okay? As the CNC programmer, I'm going to introduce a very big mistake here, an error that will cause a collision on the machine. So let me see if I can move this. No. Around here, I know that I can have a collision, okay? So let's say G0 X minus 200. So if I make this change, the PDM is gonna prompt me. Look, what are you doing here? Why did you change this? I'm gonna say optimized code. So did you mark it as approved? I'm gonna say no. You can customize your questions here. So I can go here and say, for example, that I want you to prompt me for multiple issues like, did you check the tooling? Do you update the tool list and blah, blah, blah. So let's see, logging, log chains. I'm gonna say optimized code. I'm gonna say, tooling chains. You can configure that on the PDM and you can say, did you update the tool list? Is required. Did you update toolkit? Answer is required. So now I'm gonna close this. I have like a technical issue here or something, and go to meeting kick me out, but let's try again. Okay. So I was showing, change that can be introduced by someone, right? So let's go to the machine simulation again, resume where we were. I'm going to go with the Super Mini Haas again, just to save us time. So you can see here that, we have a major collision in the process. And let me just hide the machine base so we don't have problems. Okay, so speed up. So this change that was introduced by the CNC programmer, we can now detect that. But let's say that it was the opposite. Let's say the operator introduced this. So because we have bidirectional control on the PDM, if the operator introduces any mistake on the code, before we release that program for production again, we can simulate. And if any change that were made on the machine are causing a collision or a problem, the machine simulator will catch it. So the point here, point for the machine simulation and our PDM and all that is because you have bidirectional protection. Let's say, for example, and you can quickly, control who changes what, when something is changed, why it was changed. You can roll back backups. You can, so let me roll back the good version then. I can go here to the data version is bad, right? So I can compare with the previous version and see that the mistake was introduced here, right? So this is backup number 34. I can click here on version, 34 and say store this version because this version does collision. Okay, so I go back again, open, simulate, and let's see what happens. I'm going to start from the beginning to make sure that we are simulating, we have apples to apples comparison here. It's not there anymore. But let's say now that the operator kind of, introduced an error in the process. So this is something that for years we were not able to solve for the customer. Like what happens if, operator introduced the problem? And what we can do here is just go here, I know I have an idea here in the location that I can cause a good collision. So this is going to be around 40,735. So 40,735. Let's see. Yeah, around here. So I'm going to, so Z minus, so let's say G0, X200 now. Operator introduced this error, okay, in the process. So we go here, we're gonna copy this from the CNC memory to the DNC system. DNC Max will detect the file change. I can show this to you here. And you see that, we just received a change. So look at this. At 1202, which is here, a file was received and it's awaiting for the approval of a programmer. So the change does not overwrite, the latest version of the database automatically. A programmer needs to approve that. So I'm gonna go here and queue. I'm gonna compare the change. And I can see that coordinate that the operator introduced it, but I don't know what are the effects of that yet. I need to simulate to see, right? So what I'm gonna do here, I'm going to accept the imported file, and I'm going to, simulate that. And now I want to show you the shop the SolidCAM for operators also playing a role on this. Okay, so I'm going to simulate this again. And now we have the error that the operator introduced. So we have protection bidirectionally. So now I can go here and say this program, it's failed. I can also configure this life cycles with any names I want, but for now I'm going to just go with the default names. So now this program is locked, cannot be sent to the machines because we need to fix the error that the operators introduced. Roll back an old version or something. I can compare in the timeline any version I want. I want to compare version 25, which is from May this year, to version 5, which is also from May, but compare the selected versions, and the system shows me everything that changed. So you can sell this to the customer. Imagine that you are doing, ISO 9000 one implementation, and he needs to provide evidence to the auditors about every change that occurred in the manufacturing process for the past 2 years. Let's say in the worst case scenario, there's a FAA investigation, a plane, fell from the sky, and FAA needs to start investigations, and they go to the shop that manufactured that part, and they need evidence of every change that was introduced in the process. This is how you do it. Okay, it's not a hunch or a guess or anything. It's evidence. You have dates and times and when everything happens. So you are not only eliminating paper and making a single source of truth. You are providing evidence about anything that happened. So finally, I want to show you SolidCAM for operators, which is something we want to boost the sales with this PDM technology integrated. So let's suppose that right now I have this SolidShop SolidCAM part opened. I had to restart my computer, so I didn't close it properly. Let's open this. So I want to show you how the PDM between all modules, all parts protect the manufacturing process against human mistakes. So I have this part open right now in SolidCAM, and let's suppose that I have an operator in the shop floor, okay, that wants to make a change in the process. So let's just go back here to our presentation. I want to highlight that slide with the business, with the company processes. It's here. So I have this part in SolidCAM for operators, and I have this digital ecosystem in the shop floor or in my business, this one here, right? Where CNC programming is connected to the other departments. So production. Okay, so I have this slide, and I want these guys here from the production shop to mention this. One sec, let me take this. Who is this? Hello? Okay, so what I want to do is make sure that no one is editing a file that is being edited by CNC programmers or vice versa or operators. So if I have SolidShop and I have SolidCAM for operators, let me show you how this works. Right now, the CNC programmer is on the uh, upper floor, kind of working on this part, and an operator in the shop floor tries to open the same process. So I can go here. He can do this also from the NC-based client, select the file and ask, SolidShop or SolidCAM to open this. So I'm probably not opening the same files here. Let me just highlight this. So this is my CAM part properties. I want to make sure that I'm opening the same file. So this is, yes. Okay. SolidShop for operators, close, open. Yes. Let me make sure that I'm opening this right file here. Because when you try to do this, the system will basically say, you cannot open this. It's like trying to open the same file, that is stored in the network, trying to open it from different. Yeah, you see, that's the reason. When we restarted the computer, we got the file saved as read only. So that's why SolidCAM is not detecting the change. So let me just fix this. So this goes here. This file should not be read-only. That's the problem. Okay, apply. And SolidCAM, close. And same thing here. Open. Good. Yeah. So you see, it says that this file is being used, right? So because someone is trying to use it in the SolidShop, SolidCAM for operators, right, in the shop floor, and vice versa. So one of the file because the kind of protects the file from by two different people in different locations. So they don't even have to be next to each other, because we have this protection mechanism that when a PRG file is opened, you cannot open it from another. The PDM is managing one central location, one single file to be shared in the whole company. So we have this protect them from editing. So this is the value of SolidCAM for operators working with the PDM solution, right? We also have the ability to backup or file. So imagine, for example, that you want to introduce engineering revision, okay? If you don't have like, SolidWorks PDM or Autodesk Vault, you are managing files only in Simco PDM. And you want to introduce a version control on your PRZ file. So what you can do here, before you implement the change, you can go here and say, make a backup. Now you can make whatever change you need in the SolidCAM file. If something goes wrong, you can always restore, the previous backup and ensure that, uh, you can restore your good file. And finally, I just want to show here, a basic example of editor functionality that we do not explore much. So imagine that I have a bad bearing on the machine right now, but I still need to finish a batch of parts. So what I'm gonna do here, I'm gonna go to this editor and say, reduce the feed rates by 50%, because I don't want to completely damage the bearing, but I need to finish this batch of parts before the machine builder can ship me a new bearing, because they don't have it on stock. So I'm going to reduce the feeds and speeds by 50%, and the editor, I'm going to save that, and then the editor is going to say, reduced speeds to finish this batch of parts. So now the system create a backup for us. We can, compare the changes and see that all the feeds and speeds that were changed in the whole code by 50%. I can simulate, do whatever I want. Let's say that the bearings arrived. I finished, the batch of parts. The bearings arrived and I want to restore the previous version. So I go here and select restore this, restored version 37 with original feeds and speeds. And now if I compare these two versions, I'm back to game. I have what SolidCAM computed originally. And just to kind of, force us to see a change here caused by SolidCAM for operator, I'm going to make a minor change here. And I want to post this file with SolidCAM for operators. So I'm going to close this, try to open this. So this is what I wanted to show you before. So you can see that SolidCAM for operators cannot open a file that is open in another department by the programmer that is on the upper floor. This guy here cannot open the file that this guy is working on, and vice versa, because the PDM layer will protect them from doing that. So let me close this file first. And I'm going to open this with SolidCAM for operators. And we are going to post this. So any change made by the operator, either on the CNC control or via SolidCAM for operators, is 100% tracked by the PDM. So what we can do here now, go to the database and you can see that we have a new version. If we compare this, the mistakes are no longer there. You can see the feed rate that I changed. So now I go here, log off, because I am operator. I'm going to say I am Mr. Operator. I want to see this change. And I added, in this specific example, I put operators with permissions to accept or reject files, but we can change that. We can go here to user groups and say administrators can do all this, operators have these options, and programmers have these options. And this is how I create a new user. I can say user.demo, first name, last name, doesn't matter. And I can say this user is member of operators. We also have clearance levels. We can control documentation, say this document can only be seen in the PDM by manufacturing engineers or by operators or by supervisors. So I can go here and say, hey, I have a quotation here. So I don't want, the tool catalog to be seen by everybody. So I go here on the PDM and say, this file, it's only visible by, supervisors. So the PDM also controls who can see something, even though everything is part of the package. But let's just accept this change that came from SolidCAM for operators. So with this, I finish, this first webinar covering editor very, very superficially, but NC base, the PDM. You also have MDM, which is a more configurable PDM. A little bit of DNC Max, but in the next webinar, I'm going to cover DNC Max a little bit more in depth, MDC Max, and Scheduler. And then the third webinar, we're going to talk about business, licensing, costs, and all that, and challenges as well. But today, my expectation was to show you the power of SolidCAM for operators working with the DNC system and a PDM that manages all the communication between the machines and the database, but also tracks every change that's made by CNC programmers, operators in the shop floor, or anyone that has access to the PDM database. And in regards to operators, we can track changes made on the CNC control or changes made via SolidCAM for operators. Okay, so I hope you guys enjoyed this. I apologize for the issue we had with the connectivity. For whatever reason, GoToMeeting dropped me. But I'm more than happy if you guys could send me questions or anything before our next webinar. Okay. So thank you very much, and have a fantastic day.